So good afternoon, everyone. I am Vikas Maurya. I'm Product Line Manager at ABB for Industrial Edge. With me, I have two of my colleagues, Anders Trosten, who is our software architect, and Ravi Chillerega, who is our DevOps engineer. And so a little bit about our company. So as you see, we are ABB. We are an industrial automation giant and more than 100,000 employees. We are based out of Zurich, and we are present more than 100 countries, and we have close to $30 billion revenue. And you can see, we are a technology leader in electrification and automation area. And we are primarily operating into four business areas. One is discrete automation, electrification, process automation, and motion. And we three here basically belongs to process automation business area, and this is where we are operating, let's say. And then coming to process automation itself. So what we do at process automation. So process automation is the area where we are serving to kind of our different industry verticals like oil and gas, power generation, chemical refining, pulp and paper, mining. So these are the industry verticals we are serving from process automation. And what do we provide from ABB is to all these industries is the automation. And automation is the basic focus where we build our products, basically in the automation, electrical, and digital products. All this we serve to these industries, the customers we have. And into this space, in process automation, the main thing which we offer is the DCS technology. DCS is distributed control system, and we build all our product solutions, services around this DCS technology. We are according to market research company ARC, we are number one DCS supplier in almost like last 24 years. Every year we have been ranked number one, so 24 years in a row. That is our leadership into this space. And what are the challenges we kind of work and try to solve in this space is primarily safety, efficiency, and reliability, because automation, that is what is critical. Our customers are operating very critical infrastructure, and that's where these are the foundational key requirements which we have to serve. And this we have been mastering with our DCS technology over the years, but since this space is going under transition, it is becoming more demanding and more dynamic with whole sustainability and energy transition happening, and there is a demand of agile innovation, which is kicking in. So a part of maintaining, ensuring the safety, reliability, we also have to see how we can bring agile innovation, so bring innovation fast into this space. So that brings to kind of my next slide, where we are talking about what are the industry challenges we are solving today, and what are the industry challenges we have in front of us for tomorrow. So as I said, the industry challenges, what we are solving today is really safety, reliability, and efficiency, ensuring 24/7 reliable operations of the critical infrastructure, and being really accurate into whatever we do. But as we talked about, bringing agile innovation. So agile innovation is adding, let's say, more things into it. So basically, how to bring fast modernization cycles, how to bring access of the data, and also access the IT system to optimize the processes, and how we build a system which is more scalable, modular, and an open system which can allow to connect more and more devices and more systems easily into our DCS. So that is, if you look at today's requirements and look at the future requirement, and that's what is driving us to build a future automation system. And if I talk about future automation system itself, how this would actually look like. So if we look at this picture, look at the bottom of it. The bottom is where you can see field and equipment, basically generating a lot of process data. On top, you see we have different industry verticals, as I mentioned, like oil and gas, chem ref, pulp and paper, wastewater, and all those industries. And in the middle, you would see the process automation, and that is what, as we said, ABB is offering the process automation. And on the left side of the screen, you will see how we are thinking right now. We want to have a core process control, which is focused towards ensuring the safety, reliability, the core foundational requirement of automation, which we have served over the years. But on the right side, we are trying to build something which is a monitoring and optimization space where we try to bring the agile innovation. And that is a space where we have started also using the Red Hat technology nowadays. So how do we do it? I mean, on the core process control, you see the main key item here is how do we extract safely and securely the process data coming from the DCS system, and also combining this data from other sources like intelligent field devices, IoT sensors, etc., and bring this to monitoring and optimization zone, right? That's the zone, as I said, is kicking off the agility, bringing the innovation at the speed. And that's where we start our journey with Red Hat, because you can also notice in this diagram, we have an edge technology, we have a cloud technology. So that's what we are predominantly using as an IT infrastructure to bring an app ecosystem running there, which can deliver the agility or can bring the, let's say, applications which can deliver values faster, right? So that's the space. If you look at edge, right, that's Edge Genius. That's our edge offering for this space. And Edge Genius is where we are using Red Hat technology. We have last year kind of adopted single node OpenShift as our first released offering here. We are also working on now to get the MicroShift based release out in the market, which will bring us our one of key requirement to go to low footprint Kubernetes. So that has been the key. And this edge to cloud ecosystem, which we are enabling with Red Hat technology, is allowing the applications hosted in this environment seamlessly. And we should be able to bring the applications built by our business units, our channel partners, our system integrators, our customers. If they see any kind of idea which they believe they can use to create a business application, they should be quickly convert that into an application using this infrastructure we are providing seamlessly from edge to the cloud. And we are really into how to get this done, working with Red Hat tirelessly, trying to get this reality into the market, right? So just to get more technical details on how this innovation with this speed will actually coming to reality, how we're using Red Hat products, I will let Anders talk on that more detail.
So thank you, Vikas. So the mission we got from our product management was how to introduce innovation with speed at the edge. So to understand a bit like the complexity in that, we can have a look at, let's say, the environment where we deploy Genius. So at the bottom of this, we depicted like the physical world, like an industrial plant. This is where these devices and field equipment and various production units are. And on top of that, we have an industrial control system. This is where we run DCS system. And the job of this system is to automate the physical production processes by interacting with field equipment. And this is OT world. So here, it's really sort of something which must be robust, stable, and introducing a new software version is a risky business. So undoing things here is really hard because this is physical world. So what we need to do here is to isolate a bit the edge. So we put edge on top of control layer, connected to OT network, also connected to IT network, and to cloud if that is desired. So we run applications at this edge, and we let our customers decide which one to use. Kind of like what you add apps to your phone, like add update, remove. Should be simple. And these apps that run at the edge, they need data from OT. And that's typically a challenge, how to get to that data. So what we do with Agenius is that we introduce connectivity in the platform that lets the data flow from this core OT into the edge environment, where the applications can use this data to do compute and so on. And then we let the data flow back as well into OT if that is desired. Of course, you have these different risks in OT and IT world and this border between them. So what we also do is we introduce like a data bridging layer in between here that prevents mistakes and bugs in edge applications to also have side effects and ripple into this core OT. And with this protection layer in place, we can manage the edge more like IT, like we can have frequent updates, we can have latest version, latest technology, without having to update and change anything in the core OT. And this is the foundation for innovation that lets us disconnect these life cycles. So looking at the apps at the edge, we developed these apps using cloud-native architecture principles, meaning that our apps are services. And these services would listen to input, typically over the network, and they will do some processing. They might have state. They might need to store the state at the persistent media, and they usually also produce some kind of output. They can send this output somewhere else, like to another application, or they expose endpoints, API endpoints, or web applications to our users. So with this, we need to define these apps as well. And for that, we use Kubernetes resources so that we can declare what an app is, and how we would deploy the app, what it consists of in compute, what type of infrastructure resources it needs from the environment to run, and also what constraints we need to place on this app in the environment when it is actually deployed. So this package allows us to understand and work with applications as a unit that we can handle individually. So on the hosting side, we need to run these applications, and we realized that we need something which is stable, robust, and predictable. So we looked at Kubernetes as being our operating system for edge applications, thinking them as applications only run within the Kubernetes environment, never on the OS level or anything like that. That gives us a very nice abstraction for how to define deployments and how to handle the apps. We also realized that there is no single Kubernetes stack that can scale from small, medium to large and have all the things built into it. So what we did was define a kind of like an abstract operating system for edge applications, where we bundle Linux and Kubernetes, set up base plugins, and define this as our base operating system that we can take dependencies on when we develop apps. This can also be extended by adding additional operators and custom resource definitions for those, so we can extend this OS as well. Advantage with defining it like this is that we can handle this as a single thing, separate from how we handle the apps. No. So looking at the deployment side of things, we have 3 different sizes. And the reason is that applications define the requirements. Like if we have few apps, we don't need a big deployment. If we have many, we need a bigger. If we have more data, we need a bigger. Also, location defines deployments. If we want to deploy it in the field, like in the industrial field, we need industrial PCs. If we deploy in a data center, we can have bigger environments. So with this, we implemented 3 versions of this Agenius OS. The first one using Red Hat Device Edge and Microshift, and a set of plugins there. And this means we can deploy on small IPCs, like 2-core machine. We can scale this up until some limit when Microshift no longer scales. And then we switch to use another version of this, where we base on CoreOS and OpenShift, and pretty much the same plugins. So, and then we can, of course, go to multi-node and we can scale out this. So advantage we get from this is having this one trusted environment where we can run the same applications everywhere. We can use the same processes, the same know-how, the same tooling on all these environments. And with that, I hand off to Ravi, who will talk a bit more on how we actually realize this small edge.
Hello. Thank you, Anders. So I'll talk about a Genius OS and how we have packaged it. A Genius OS is a purpose-built operating system that we are building and packaging on ABB side. This is basically based on Red Hat Device Edge and Red Hat OpenShift Kubernetes engine, that is MicroShift. On top of MicroShift, we package OpenTelemetry for observability. We're also packaging Cert Manager and a Genius applications. One of the basic there were 4 aspects that we looked into when building this. I think one of the first one was that we should be able to set it up in an offline manner, easy system updates, ensuring easy monitoring of the edge, and also ensuring that it is completely secure by default. So to ensure a completely offline system, we ensure that the Genius applications, OpenTelemetry, MicroShift, Cert Manager, all the container images of this are baked into the image itself, so that when you just install the ISO, it just comes up. And there we are also using the aspects provided by MicroShift, where you can auto-apply Kubernetes manifests at the first boot. We are also using our own update manager on top of the RPM OS3 update, mainly because we also use RPM OS3 as updating as an update mechanism for our applications as well, not only for the OS. And we have 2 variants of the OpenTelemetry. One is on the node level and one is on the Kubernetes level. The node level OpenTelemetry is basically for journal logs, also meant for collecting the node metrics. And the OpenTelemetry on MicroShift is basically for application metrics, Kubernetes events and Kubernetes metrics, and Kubernetes container logs as well. So going ahead on it, how do we build this? We have used the OS3 mechanism, that is OS3 and Composer CLI. Basically, we go ahead and compose the sources, create an edge commit that is available. Once you compose the sources using Composer CLI, sign it with GPG keys, and then create a container image. This container image is the same one that we actually use to update the OS as well at a later point of time. And from the same container image, we also create the final ISO that you can actually just install on your system and bring an edge up. Going ahead on the installation and update management, there are 2 variants that we are looking at here. One is a completely disconnected scenario. That means a completely offline system where we have a local application management. We take an ISO on a USB device or a network connected through a local network. You can actually set up the edge very easily. And what would happen is that the software distribution is also is done in the same manner. We use container images, again, to actually update the OS. And we have local monitoring solutions using OTel collector, which can connect to the end customer's monitoring solution that they have. For the cloud-based, we can manage it through ABB Cloud, where we have application management that is available and the fleet management of edges that we can actually do. And the OS update is also handled from the cloud. That means we push the container image down to the MicroShift cluster, and that allows us to update the OS on a regular basis. Yeah, so that was from our side, from ABB. Thank you all.